Thank you for the introduction. I'm Mariia Zhuldybina. I'm an institutional researcher at École de Technologie Supérieure at Montreal, Canada. And I will be talking about electronic textile printing for sensing wearables. So my background is in printing. I was working, my PhD was done in printing electronics, and then I was working in the industry. And when I became an independent researcher, I was wondering what I can do with printing technology for wearables. So today, we are talking often about Industry 4.0 and the connection of everything. And in this case, our wearables becoming even more smart and smarter every day. And it's not only about fashion. Right now, it can detect and sense many things. And for example, here, like a Hexoxine t-shirt and the top from Mant is the Canadian companies, they can detect their do some health monitoring and training assessment, as well as the EVO company, which is creating the wearables which can adjust the temperature condition and make it warm when it's cold and vice versa. And with this development, today, majority of this kind of application are done by collecting like the fabric part. Then we take different pieces of electronics and integrate it into it, and start doing reading and sensing which is needed. And in our case, we were questioning what we can do to avoid this integration and to make the textile, the wearables, more comfortable, breathable for users. And what we propose to use the textile as a substrate. So there are many types of the textile which are existing today on the market, and all of them, they varies in terms of the type of the fibers which are used there, how they place in each other. They can be organic, they can be synthetic, and many of them. And for initiate our work, as I say, I wanted to see how can we apply printable techniques for textile. We choose the Oxford textile, which is it has less porosity and it's not stretchable, because if you add stretching is already at a level of complexity which arrives, and it requires more study to be done. So we started with that, and then we also explore what kind of fabrication techniques existing for deal with textile. And from my heart, I like screen printing and inkjet printing, or any type of printing the most. And for initiate the work, we started from screen printing because it's one of the most accessible technique. It allows to use for versatile materials. And for example, if we compare it with inkjet printing, which digitalize, the speed of the manufacturing with screen printing is much higher can go, and we can pattern bigger surface area and many more advantages. And moreover, screen printing has been used many years in the textile industry for patterning, like some designs on the t-shirts, etc., with colorful ink. So we printed the first trial simply we did. We compare the performance between PT, which is very wild use and very well known. And you can see very beautiful print with very well-defined lines. And then we print on the export they use absolutely the same parameter in terms of the printing and drying afterwards. And you can see there are many more cracks which are appearing and discontinuous in the line, which obviously leads to the lower conductive properties. And then what we have done, we have learned that plasma treatment exists already for a while, and it's very well known in order to modify the surface energy. It has a lot of advantages, like, for example, the first is like it avoids all the contaminants appearing in the surface, as well as it changes the surface energy, so it makes it more accessible for the inks which exists for the print on the substrates made from plastic. And it's also react only with the top surface, so it doesn't modify at all the fibers. And we have done the printing again with the same conditions by modifying the plasma treatment timing. So we use the same power, and you can see here from left to right degradation, like improvement, I would say, in terms of the quality of the printing. So on your left, you see the printing on the textile without any treatment, and on your right, you can see the printing on the textile during 4 minutes, and we can see drastic improvement in the visible condition. Yeah. Also, if you look, we printed the simple Air Force pattern just to see the resolution, how it affects. And if you look on the, like, I zoom in only the biggest structure, and then if you evaluate like last two pictures, like the last pictures on your right, it will be the quality even of the thinner lights improves, and they only right now like defined because there are discontinuous appearances because of the mismatch on the mesh size and the fibers of the Oxford textile which we have used, which can also be improved by replacing the mesh size. So basically, what was important is to see what is happening with electrical properties. And here I showed the result for two inks. We just wanted to see how consistent it is, the approach which we are using. And we can see that it shows absolutely the same dynamic between, in terms of the increasing the time duration of the plasma treatment. And the conductivity is improving, is getting better because of the modifying of the surface of the textile. So the conclusion of my presentation is very short, is really, as I say, like it's preliminary result which we got with my students. We just started to try now to print on textile, and we have shown that by improving including the surface treatment before the printing, we can improve the resolution of the printing electrical properties, which is very critical. And further on, we understand the importance of looking for the ideally sustainable encapsulation layer, and do tests on the washability and mechanical tests as well. And we see with further application of the heated elements made on the textile directly without any, as I say, additional integration, for working in the harsh cold environment, which is very important needs in the work environment in Canada. Thank you for your attention. And also, I'm looking for PhD students, so I don't know if any of you are interested in the auditorium, but please contact me. Thank you.